Just tell me if it.
Hey everyone, we're live here with Harry, co-founder of NIM. He'll be doing a talk on holistic privacy, why zero knowledge proofs are not enough. And I'll let him take it from here. Can you guys just confirm that you can hear him?
Yes, can you hear me? Can you see me? I'm going to go to full screen mode on the slides. Is everything good? Yes, no? I need some feedback. Maybe no one is listening. Okay, great. Okay, so we're going to start with what's called, my talk is called Holistic Privacy. I'm the founder with Claudia and a few other folks of NIM Technologies. So we build mixed nets. And a mixed net has nothing to do superficially with zero knowledge proofs, but has a lot to do with being anonymous and private. So I'm going to explain why that's important. Zero knowledge proofs are interesting. I learned about them from my old office mate at Madars Versa at MIT. And then I just want to point out that the term itself is a great triumph of marketing, but there's tons of confusion around the term. So for example, the vast majority of work that we've looked at, like ZK Sync or the ZK rollups in Ethereum, are for scalability, not privacy. And in fact, the term is so popular that I would say there's a huge problem where basically everyone just kind of wants to throw a zero knowledge proof system on things and somehow magically call themselves private. So we've seen this with everything from privacy enhanced DeFi, where I've looked at the code of some of these systems and it just makes no sense what they're doing, but they advertise zero knowledge anyways. There's lots of workshops and newsletters and stuff, but the fact of the matter is that the amount of people who can actually write zero knowledge papers, which are very difficult cryptography involving pairing and lots of other things, which can't even be formally verified, is far less than the amount of people that can implement ZK systems, which is incredibly hard. And groups like ECC are, I guess now they're bootstrapped, are very good at it. That's really amazing. But they're just dwarfed by the amount of people that like the term. And there are cool technologies, Starkey and Socrates come to mind, which will help you learn about it. But what I want to point out is that zero knowledge proofs are just a tiny part of the issue with privacy on the internet. So you can have, the main thing you got to think about whenever you're building a system is what's your threat model. So when you look at privacy definitions from zero knowledge proof papers, you have some sort of bounded adversary. You basically are trying to prove something without leaking any knowledge, and they have a transcript, and you kind of statistically beat them over time. I'm sure someone else will give a better intro talk, but it's an interesting but perhaps not particularly realistic adversary model. The realistic adversary model, as we know, is the NSA, and they're not particularly interested in looking just at on-chain transactions. Why would they be so limited? They're looking at all of the inputs and the outputs of the network, and particularly things from the ISP, things from the IXPs. And this threat model, just so people know, is excluded and rightfully excluded from Tor, which lists that explicitly in the original paper. And furthermore, in most systems, like including NIM, we're interested in also defeating malicious node operators. So when you build a privacy enhanced system, you can't just become completely obsessed with a single cryptographic primitive. There are different levels of abstraction. Obviously, if you've ever done anything on the TCP/IP level, you may be familiar with what's called the OSI model, which is a classic case of levels of abstraction. So you have applications, which are on top of sessions, which are on top of transport, which can be encrypted via TLS, which are on top of networks, which have a sort of logical addressing mode, which are on top of link levels, Ethernet addresses, and finally bits and frames and MAC addresses and whatnot. And this is very important that if you're really trying to build a privacy enhanced system, you don't just focus on one layer. Obviously with a blockchain, you are sort of self-surveilling yourself. You're sort of putting in a ledger, unlike previous eCash systems like Chom's original DigiCash work. You're putting in a decentralized ledger, basically all your transactions to be harvested. But even if you do things off-chain, Lightning, for example, layer 2 solutions, whatever, even things off-chain can be monitored by looking at things like the network level. And I just want to disabuse people of this concept that there is a silver bullet for privacy. Holistic privacy means that privacy leaks at one layer can affect all the other layers. So it doesn't really matter how private you made yourself on chain, or if for a powerful attacker if you are leaking stuff on the network level. And I'm just going to use a non-ZK Snark example, just so I'm not thought upon as singling them out. But let's look at SGX, right? So SGX sounds amazing. You can do privacy-enhanced computation. It's defended by magical hardware. But the fact of the matter is researchers look at the magical hardware because it's not really even SGX's fault, although it isn't that well designed. It was built for DRM, not server-side attestation. So SGX is built to prevent you from streaming Netflix, not to secure your cryptocurrency on a server. But regardless, even if you try to use it that way, the very fact of the matter is physical reality has side channels. And this is just true. So of course you're going to have lots of different kinds of attacks on SGX, Meltdown, Spectre, Foreshadow, and they're all fatal in their own unique way. And they can all be fixed in their own unique way. And you can make SGX kind of reasonable if you devote half your RAM to fixing those bugs. And there's great new stuff coming up like Open Titanium and some of the stuff from Project Keystone from Oasis. So we do think there's a future for secure enclaves. But I think everyone just saying, oh yeah, SGX equals privacy against DeFi, that's absolutely ridiculous. And people should call them out for that. And this also applies for zero-knowledge proofs. They're not magical, right? It's a very fragile construction with a very limited threat model with issues and verifiers. It, of course, has a trusted setup. There's cool things like Sonics to help that out. But also, let's be very honest, ZK Snarks has trusted setup because most of modern cryptography has trusted setup. When you're using PGP with RSA, the P, the Q, the N, the key size, that's all trusted setup for RSA. So let's just be very clear. Trusted setup is not actually the worst problem with ZK zero-knowledge proof-based systems. But zero-knowledge proof systems, because very few people do actually understand them, even though people like to talk about them, they are incredibly difficult to audit. And they're incredibly difficult to audit because they're not built, they're built for general purpose computation. What someone has called moon math, is conversion of essentially general purpose computation to what's called arithmetic circuits. And this is amazing and worth a tassel of Nobel Prizes. But ultimately, simpler constructions, Schnorr signatures, Sigma proofs, actually make sense. And then a lot of the latest stuff in the zero-knowledge world, moving different mathematical hardness assumptions. I mean, few enough people understand pairing-based crypto with fairly straightforward assumptions around the thing, it moving to like other assumptions makes it even harder. So if you're using something like Zcash and you're not using network level protection, there's an old saying in the IETF, the Internet Engineering Task Force, where I used to work, where they said, well, the weird thing about TLS, about encrypting your traffic, is it's like using an armored car to deliver messages between two homeless guys living on different benches. And zero-knowledge proofs on the blockchain is sort of backwards, right? ZK Snarks on blockchains without peer-to-peer protection is literally like two armored cars communicating to each other over something mission critical with paper airplanes that anyone can just read. So we need to do a bit better. And we really have to hammer home the point that ZK Snarks on-chain or any ZK relative, ZK Snarks, et cetera, do not provide any privacy in the network level. And network level is actually where folks like the NSA and Chainalysis attack. And it essentially serves as a side channel that can de-anonymize on-chain transactions. And observing small, even layer transactions on peer-to-peer networks is easy. Chainalysis was doing on Bitcoin because these peer-to-peer networks, to be honest, for most things, Bitcoin's like 6,000 or 7,000 nodes. For Zcash, I couldn't even figure it out, but it's like a few hundred, right? These are tiny networks, easy to observe their broadcast. And again, every network is broken in its own wonderful way. So, of course, there's lots of different things happening on-chain. And on-chain, zero-knowledge proofs does seem to be the best way to go compared to ring signatures and other sort of things. Mimblewimble is pretty broken in terms of privacy. But regardless, the real issue, again, let's point out, think holistically. Look at the whole system. Let's look at all different layers. So Bitcoin uses some crazy custom TCP/IP peer-to-peer stuff that's pretty not so great with a very limited number of seeds and no encryption. Ethereum tries to use encryption, but then shrunk the node size, and it's a total disaster. Even less nodes for initial seeding. Zcash just copies Bitcoin. Monero tried to use I2P, didn't work out. Other things do even worse. So you don't really want to. It's a disaster. And our solution is that we think that people should just use Zcash or Monero or whatever with something like Tor and mixed-nets. In fact, as the quote shows, it's even mentioned in the original Zcash paper. Thank you, Ian Myers, who I believe is speaking later today. And so what we did, because I'm interested in studying holistic privacy and understanding how users think of it, because the fact of the matter is we can design some perfect system on paper, but unless that system actually maintains privacy in this kind of systematic, holistic fashion to some high degree of certainty with actual users, it's maybe kind of pointless. I mean, maybe a fun academic article, maybe great to do a PhD thesis on, but not something that you want people using in product. And again, the vision of product, something like dark wallet for privacy enhanced cryptocurrency, has been around for years and has not been really fulfilled. So I took the best I could find at the time, which was a few months ago, the ZEC wallet. We did a bunch of user studies, about 60 folks, and from a wide variety of places, including Africa and mostly male, but not all. And a lot of people are hiding their gender, and wide variety of operating systems. And, people were fairly expert. And I said, hey, can you use ZEC Wallet Lite to do a transaction? And the answer is, I'll go through this very quickly so we have a little bit of time. We had them install ZEC Wallet. We had them set up a wallet if they didn't have one. Write down their seed. Sync with the blockchain, which takes a little bit of time. That's why I have forced use of Lightwalk, because a lot of people didn't have time to download the full node. See if they could distinguish between shielded and transparent Zcash. Figure out they could go to a simple website like whatismyipaddress.com, get their IP address. From that, we want to note that Zcash, ZEC Wallet Lite, and Nighthawk do not currently work with SOX 5 or any of the HTTP parts of the Tor, so they don't have Tor built in. And also, if you're buying something online using something like shielded Zcash, you don't want, and this is a very subtle point, but very important to remember. If you remember Claudia's talk, she says, mixed nets mix things per packet. But Tor opens what's called a circuit. So what that means is all your traffic goes to the same circuit for 10 minutes, and then it's switched. So what does that mean? Well, when you have a packet thing switched by packet, every packet is mixed, every packet is private. In Tor, all the packets are the same for about 10 minutes and they switch. It's quite good at hiding your IP address for 10-minute intervals, but very poor if you have a single SOX 5 client and you're running your Zcash wallet through it and your browser. The fact of the matter is both those things are coming out with the same IP address. And we've asked them to fix this and it hasn't been done, but eventually get around to it. So what you have to do, which is a little bit crazy right now, if you want to use Zcash with network level privacy, is you have to install a VPN and a Tor. So what you want to do is you want to send all the traffic from Zcash through the VPN, and you want to do all your web browsing on some cool Zcash enabled website via Tor. So we gave people Mullvad VPNs, which were free, and they were thank you Mullvad, they were very nice to us. They paid for them. It took a while, they got Mullvad working, and then we said, okay, well, let's install Tor, and they were going to try to get Tor working and test Tor out. And yep, indeed it does work. And look, the Tor IP address is different than their actual IP address, and they went to this wonderful website called najala.law, ran by the ex-Pirate Party people, and tried to buy an anonymous domain name, something many of us would like to do, maybe if there are sketchy privacy-enhanced DeFi projects. And indeed, they tried to buy a domain name, and you could use shielded Zcash and Monero. And there is this irritating registration phrase, but you can, of course, make a private email using a service like RiseUp and pay using Zcash for your new anonymous domain name. And with that new anonymous domain name and server, you can run a Tor relay. And this is all great. And we were very, very happy to go give this giant workshop for people. But what we discovered, and you can do lots of things like run tails, or if you're in China, shadow socks, is that, let me just skip to the end really quickly so people can see the results, and I'll go through NIM, is that the results were unfortunately not very good. So only about half the people managed to get Zcash working. A lot of other people got confused over shielded and transparent transactions. About half people got the VPN or Tor working, but only, about 1/3 of people could actually do the entire transaction. Most people kind of forgot the differences between shielded and transparent transactions. People got confused about if Zcash works on exchanges or not. People were distrustful of Bitcoin and VPNs and more comfortable with Tor, but they kind of thought they were traceable. So what we're doing at NIM to make you a little bit more untraceable, and then I'll just finish up really quickly and hopefully have time for a question or two, is that we basically have built a new kind of system, which Claudia described abstractly, and I'll describe a little more concretely, that you see a VPN, traffic goes through, comes out, but the timing and volume is the same. The Tor, you just monitor the entry and exit nodes, it's the same. So NSA can obviously van you, so to speak. So we built a mixnet based on Loopix, which is online. It's a great design that adds dummy traffic and timing obfuscation to Tor. So that means that the packets are mixed at every hop per packet, and little bits of latency are added. And this means that the packets, all being the same size, because they're using Sphinx like Lightning, can come out and actually be anonymous. You can see, compared to Tor and VPN, it's a very different design, different layer topology, but nice sort of results. And now we've installed it. We got working with SOCKS 5, so you can actually use NIM Mixnet today with Bitcoin and Firefox. And in fact, there's so many people joining our network, which now gives people Bitcoin and NIM testnet tokens to run, that we have 700 some nodes, which is about 1/10 the size of Tor. So we're actually making a lot of progress on getting a real world mixnet going. And we plan to integrate, we've integrated Bitcoin and Liquid first, but we're looking forward to integrating Zcash and Monero in the future. So again, one does not simply access the dark web. You got to think holistically. It was a very quick tutorial, but the whole thing is online. If you go to Consensus and search my last name from Consensus this year, and maybe we have time for a question or two. Thanks a lot. That was very fast. I actually did it faster than I thought I could. So do we have any questions? Okay. I see 4 questions. I don't know if I can access them. Okay, excellent. Yes. Okay, so that was perhaps too fast, but we can ask questions about the various parts. But effectively, I'll just give the TLDR again. Zero knowledge proofs by themselves aren't enough, but they're a great place to start. They are the best on-chain protection, but they're not magic. In the same way that SGX is not magic, and there is no magic in reality, so we just have to get used to it. And we should defend the network level. And I honestly think mixnets are the best way forward. Reasonable people can disagree. I just think those reasonable people are wrong. Anyway, so yes, you begin by showing how many, most, or all of live production blockchain networks don't offer very good privacy. Is there anything that new networks can or do that are easy wins to improve privacy? So I would actually really look carefully at your peer-to-peer layer, and at least make sure that when you have a wallet, so it's very hard to, and I have a whole paper on this called Decentralization Privacy, the Long Road. It's very hard to make peer-to-peer traffic private by itself. So what you really want to do is you want to make sure the user can defend themselves and aren't de-anonymized themselves when they use the peer-to-peer broadcast system. So something like basically allowing your wallet to natively hook to something like Tor or NIM or even a VPN, building that in so the users don't have to do all of the terrible stuff they did in our exercise and try to install different pieces of software and they don't really work and they have to install one thing for their browser and another thing for their wallet. If you can make it's really a wallet issue, I think is the easiest way to solve it, is to get your wallets working. In terms of the actual peer-to-peer traffic design, Dandelion is a big advantage over what a lot of other stuff do. It's not encrypted, blah, 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 but at least it doesn't directly leak your IP on the first hop. So I think it's essentially like a VPN for your peer-to-peer traffic. That being said, of course, a powerful adversary can watch some percentage of your peer-to-peer traffic and figure out and quite easily break Dandelion. So it's obviously, again, not magic. And in that case, I think the thing that your networking level should do is that there's different mistakes. This might be a whole different talk that Ethereum and Bitcoin made very differently in terms of their peer-to-peer layout. And I actually would say that obviously, the sort of encryption used by Ethereum is good, but the reduction of the space of nodes and their naming pattern is very bad. So you have to look at that. And the hard thing you can do if you're really interested is try to implement something called Shadow Walker by Pratik Mittal. Okay, so here's another question. Existing deep networks have 3 major issues: ISP discrimination, server discrimination, and in-network asymmetries. The answer is yes. We have worked on all these 3 questions, although we only have a plan for 1 and we are working on 2 now. So ISP discrimination, everyone kind of beats it the same way. So it used to be DNS fronting. No one really does it anymore because basically Amazon and Google and friends turned it off. But effectively what you can do is use obfuscation proxy. And that works on the first hop, not only into Tor, but into any network. You use it with VPNs. You can use it with NIM. And NIM is set up so that the first hop can do that. The problem with obfuscation proxy 4 is that, it's very hard to beat a machine learning game against a powerful adversary, particularly, say, China or even the US. So what we've seen, and at least we haven't had huge censorship in the US yet, although we can wait for the election. It'll be very exciting to see what happens then. But up until then, we do have a lot of experience with China, and it seems like in China, VLRay, Trojan, various Shadowsocks variants work really well. So you can also use the first hop of Shadowsocks, and that's something that at least some of our users want us to get going. So we'll just, again, for number 1, I think you just copy what VPN Tor providers are doing, and that can be done by wallets as well. It doesn't have to be done by, if you were talking to your wallet server, your light wallet, you might want to do that to disguise who you are. That if your network level adversary is trying to block your access to that wallet. Server discrimination and in-network asymmetries, like being DDoS, et cetera, is really basically a issue of someone is essentially shipping packets to the network too fast or in a very directed way at a particular node. So this is some sort of classic DDoS or Sybil or flooding attack. And with mixed nodes, it's kind of the same, where the mixed node is just somehow delaying or dropping traffic rather than mixing it. So how we solve this problem with NIM is we use verifiable random functions and a joint randomness pool. Again, similar to Tor. Tor has lots of great things in it. And we use VRFs on top of that, basically to produce a little tiny proofs in the packets that you've been randomized properly. And we could verify those. And so this, in theory, basically says, even though you choose the latency that you want to go through the mixnet, you do use source routing, because otherwise, if you are not doing source routing, you're doing peer-to-peer routing, as Claudia explained. There's lots of attacks there, and the peers will drop it. So systems like Hopper or I2P and all these other systems, they're very affected by these attacks. And we think these problems are minor, minus some giant breakthrough, probably unsolvable. But that does not mean that you can't use source routing with verifiable randomness. So that means that I, as the source, as the sender of the packet, can send my packet to the service that I want to go, but just the path that packets take, even if I give it the average timing, the exact timing delays are not set by me, but set by a verifiable random function, which then can be verified. And that really is, I think, the only way that we can think of to stop those 2 other attacks. Can we have links to get more info on how to use the NIM network as an app developer? Yes, it's on the slide. You go to nimtech.net, you go to our Telegram channel, and we have a /docs, and we have some early app developer documentation there. It's not so great, but we got it working on Blockstream Green, Electrum, Firefox. It's not impossible if you have a SOCKS 5 proxy, and you can even build in-library linking if you're really determined. How efficient is mixed networks for networks with millions of transactions per second? It sounds like it's bad, but it's actually not, because how do you say? The per packet delays end up being, we're not talking seconds or minutes, we're talking milliseconds. So what we've seen is we can stream, and we have a video of this, we can stream video through the mixnet if you set latency down low. What you have to do is you have to sacrifice latency. You have to sort of say, I would like to be as fast as possible. And the crypto itself is heavyweight, but not so heavyweight that it's more heavyweight, much more so than other kinds of packet encryption like IPsec. And the mixing is not so heavyweight, it's the timing delays that's heavyweight. And the timing delays is kind of what mixing is in a Lupix style system. So what you want to do, rather than what you want to do, if you really want lots of privacy and you want high speed, you just have to have a network that has lots of traffic. Because even if there's a network and basically no one's using it, or very few people using it, you can get a large amount you can be anonymous pretty well, but you have to slow that traffic down. You have to make it really slow. And if that traffic's really slow, then yeah, you'll be anonymous because everyone's kind of really slow together. Everyone's in the same set. If you have tons of users, the nice thing about mixed nets, unlike blockchains, is they scale horizontally. So you have more, you want more, there's sort of more desire for more traffic. You just add a new mixed node. And that means that there's not this like competition for block space or these like weird peer-to-peer things. We have too many peers and you have issues with DHTs and stuff. And you're like, oh, who am I talking to? No, it's like pretty efficient insofar that you can still maintain privacy, but you have to have lots of traffic. And if you and the more traffic you have, the less mixing you need, and thus the less timing delays you need. That lets you speed up. So I believe it can be efficient for networks with millions of transactions per second. I'm pretty sure what we have right now would work on all of cryptocurrency, but cryptocurrency isn't millions of transactions per second. Can NIM use network observation traffic tech like observation 4? Yes, to hide NIM traffic. Yes, that we can definitely do that. We do not do it now, but yes, it works. Yo, you contact me on Telegram. That's my Telegram handle. It's at Harry Halpin, and we have a whole Telegram chat channel. So we're more than happy to chat with people on Telegram. What exactly is NIM? NIM is a mixnet. It's like a next generation anonymity network that mixes everything per packet. So you have, in maybe an ideal world, you have some awesome zero knowledge proof thing on chain. You got a mixnet running beneath it. And then we didn't even talk about the kinds of attacks in the layer above. We're going to make sure that Najala or all these layer 2s or these websites or services also are privacy preserving and not, so if I'm using a mixnet, I'm using Zcash, I'm shielded, that's amazing. And maybe I'm using Bolt for layer 2 and I'm so cool. But if the website asks for my phone number or my real name or my shipping address, which may be important for people, then I'm screwed. So that's important that you don't leak. Leaking is also going to happen at higher levels and leak down, not just leaking on lower levels of the network stack and leaking up. For the thing about decentralized privacy, I'll just put the link in, but it ends up being much harder than we thought. Essentially, the main problem is that you really can't, I'll just summarize the paper, decentralization and privacy requires advanced cryptography. There's no way around it to our knowledge. And that includes zero knowledge proofs, but not limited to. What's the current status of the NIM network regarding the need for uniformity of traffic patterns? We basically make them uniform, so we don't need uniform traffic patterns. We may just slow you down a bit if you're really not uniform at the current state until we get more traffic in, then we can speed everyone back up. No, we are not looking to be a single, yes, we are. We do want to be a mixnet for lots of different purposes. And I will have to leave in a few seconds, but let me see. What's the business model of the NIM project? Well, I think if privacy is important for people, which I know it is for lots of folks, certain apps will be able to pay for access to the NIM project. And just like Bitcoin, you have these transaction fees and you use Bitcoin, you'll have a privacy fee. And that small fee can then feed the mixed nodes. And that's, I think, probably sustainable. So thanks a lot, everyone. I got to go. I'll be in the chat channel for a bit and we'll drop some links there. So that was a light speed talk, but I only had a half an hour. Hope you survived.
Harry, you did an awesome job. We can either transition to the next session now, or you can take one last question if there are any.
Okay, is there any questions in, let me just, any questions in the chat channel? Basically privacy is really hard, and zero knowledge proof research has done amazing things, but let's not get too obsessive. There's a lot of other things that need to be done. And obviously we need more people doing peer-to-peer research. I know like Status and the YQ people are doing it, but it's shocking how little research is done there. And also we need actual privacy enhanced apps and layer 2 solutions as well. And a lot of the ZK rollup stuff I looked at, I've been very disappointed in because it's focusing on scalability, which, to me, I'm like, well, that's Ethereum's problem. I can just use another chain, and not focusing on, like maybe that's not a problem on Polkadot, for example, or not a problem, and not focusing on actual building privacy enhanced services like Najala.law or Najal.law, which I think will drive users, because the best privacy in the world, there is no global anonymity set. There's no magical way to be private. You will always be limited in any privacy enhanced system by the number of users of your system. And so you have to get large systems that blend large numbers of users. Otherwise, because physical reality does not care about your mathematical proofs, physical reality will say we can tell who's talking to who on the link level and network level, and that's going to be your max anonymity set size. So, okay, thanks a lot. I'll stay in chat for a bit.
All right. Thanks, Harry. We're going to transition to our next talk now.